Hi friends, very good morning to all. Today I am here for giving lecture on cardinal points and Newton formula and graphical construction of image. This video for BSc third sem students. This topic comes under the uh, optics. So in previous class you will discuss about the Abbe sine function and Lagrange's equation and Hamiltonian's and Lagrange's equation. So basic things you already derived and explained about, you already studied. So in this class I am going to explain cardinal points. I explained this topic. Again I am going to explain by this slide. You all are know about the lens. So without a knowledge of lens, convex lens and concave lens, we will not understand the topic. So you all are known that lens is an optical device or optical system. It having bounded by two surfaces, and if middle is thick, that is a convex lens. Middle is thick and edge of the surface is very thin, that is a convex lens. And it what are the rays is fall on the convex lens, it make to converge the principal axis. So and concave lens, that is another type of the lens, and in this case middle as it is thin and edge is very thick, so we can easily find out which one is convex and which one is concave. So these are basic things. By what is the use of studying the cardinal points? So in lens you are also number of lens. For example, in one lens it gives the image clearly. If you number of lenses are used, the image should be more clear compared to single lens. You all are using your eye by the lens. So what is the purpose? Because you have to see the object more clear if you have any defect in your eyes. So like that. So number of lenses, it gives the more clear image. And also if you thicker lens, by optical system there is a optical equivalent system. So there is one experiment, serial goniometer. You will understand more by practically. So today my discussion is cardinal points. The next slide we can see here. For example, introduction. So lens is an optical medium bounded by two spherical surface. A lens which has thick at the middle and thin at the edge, already I discussed, that is a convex lens. A lens which has thin at the middle and thick at the edge, that is a concave, that is diverging lens. So the focal length, so already know the focal length. The focal length of the lens depends on the radius of curvature and refractive index, that is Ri, and the radius of curvature. The distance between the optical center of the and radius, that is center of curvature, that distance is radius of curvature. An optical lens consisting of thick lenses or a number of lenses kept in contact having 6 important points that are called cardinal points. What are cardinal points? These are the points, they are present on the principal axis. They are helpful forming the varies the image and clear what is the size of the image. These all are what there are cardinal points. There are 6 cardinal points, that is 2 principal point, 2 principal foci, we can call principal foci or principal focal planes, and 2 principal points, 2 principal focus and 2 principal points and 2 nodal points, and corresponding their planes, 2 principal points, 2 principal focal point and 2 nodal points, and corresponding their planes. How they are getting, you will understand one by one. So again I will say in this slide, first and second focal point. First one, the first focal point and second focal point. These are the 2 pair of focal points. And the second one is first and second principal point, that is 2 pair of or a pair of principal points. And first and second nodal points, that is pair of nodal points, that is the first nodal point and second nodal point. There are totally 6 nodal points are there in optical system. Next, how to understand this one? So for example, right here, it is an lens, that is a convex lens. If you draw the center in this lens, that is a principal axis. For example, x and x dash are the principal axis. Let us we assume that they are parallel, that is a red color. The parallel rays here, lower side and upper side, they are incident or fall on the this lens, and the property of this lens, convex lens, that is going to converges, so where this is the image point or image space, it is the object space, you already know. So in image point, where is these rays and incident on the principal axis, that point is a second focal point. F is the focal point, second, that is 2, second focal point. That is, there is another condition. If there is a point, the rays are starting from here, principal axis, and incident here in upper rays, and there is a lower rays, that is incident here. And what are the rays incident like from principal point to this convex lens, that make to passes through the parallelly. So what are the rays incident like from principal point to this lens, that makes to pass through the parallel beams? So that is blue color, whatever. So what are the rays starting from this point, that is the first focal point? Look at here, a pair of points lying on the principal axis and conjugated to the points at infinity to are known as a focal points. So the rays incident, it is comes from infinity to and makes meet at the principal axis. In this case, the rays start from principal axis and they are go away from the infinity, so like that. So these two are F1 and F2 are the conjugate points, they are lying on the principal axis. These points is known as a focal points. Are you understand? A pair of points lying, that is lying, F1 and F lying on the principal axis, and conjugate, F1 and F2 conjugated to the points at infinity are known as a focal points. So the points on the principal axis in the object space, so that their rays starting or appear to start from it, become parallel to the principal axis. After refraction, the lens system, the first focal point, that is first focal point, they are start from the principal axis and they are passes away from the and meets at the infinity, or go to the infinity, that is first focal point. Yes, so here that is F1. At the point on the principal axis, the image space, here image space, so that the rays parallel to the principal axis, image space. So you can see here, there is a principal axis, the rays are parallel. Principal image space for focus for the appear, and the point after refraction from the lens, they are second focal point. So that is second focal point. This is the first focal point, this is a second focal point. This all are about the convex lens. Same here in concave. Same here also, the rays incident here, and they are in case of concave, they are diverging like that, and here lower layer also rays are also they are diverting like that, and they are rays start from here. For example, here the rays start from like, and they are passes like or makes, when it is passing the concave lens, they making the parallel rays, and here also the rays incident and making the or passing from this point, it makes the path is parallel. So in this condition, how to take the F2 lines or F1 line? So whatever you have to draw, like when the rays is incident and goes away from that infinity, and you draw the imaginary line and meets that point to principal axis, that point is a F2. Here also, when the rays incident and passes away from like that, you draw the imaginary line and that should be meet at this point, that is a f2. And same condition here also, when the rays are incident and makes the parallel to principal axis, the rays extended part when in this point that meets at the principal axis, that point is f1. Same here also, when the rays incident and makes to parallel, when you have to draw appear to meet at this point f1, that is extended part, that is f1. This in this condition concave lens you have to make it like that is f1 and f2. Next, if you in f1 if you draw perpendicular to this principal axis, that is a principal focal point. Look at here, that is f1, the first principal focal line, the plane passing through the first focal point, the plane passing first focal point and perpendicular to the optic axis, that is principal axis, that is the first focal plane. So these are the plane that is perpendicular to principal or optic axis that should be drawn in the first focal point, that's why first focal plane. Same here also, the line or the plane passing the second focal point and perpendicular to the optic axis, that is the second focal plane. Look at here, the plane passing the second focal point and perpendicular to optic axis, that is second focal plane. So these all are about the focal point and focal planes. Next you will start or learn about the principal points, how to arises, how to get the principal point. Same here also, it is an optical system, it is a thick lens, draw like that. Here one surface, another is here, there are two surface, this is a principal axis, the ray start from A to B, it is an incident ray. When the rays is passing from this thick lenses, so that is dot line, then the light rays passing or under the optical system. When it is comes at this point and it going to refracted and meet at the principal axis, this is the image point, that's what that should be denoted as f2. So the rays start from this principal point in object side and meet at here and makes the parallel after the refraction. So the ray starting here and meet at this point m1. How to get this m1 and m2? So what you will do that when the rays start from AB and incident and refracted C2 to F2 and you draw extended part or you take the reverse or dot, make it dot, and the rays incident and refracted and makes the parallel, and also you take the imaginary, that is reverse, and where it is these 2 points, this one and this one, you draw the perpendicular point where the line is meet, that is the second principal point. See here, same here also, when the rays is incident and this extended part here and the incident ray extended part where it is meets and you draw the perpendicular line, that is the first principal point, and the normal or the plane is drawn, that is the first principal focal plane, it is the second principal focal plane. When you are drawn the point here in the principal axis, that is a second principal point, this is a first principal point, that is H1 and H2, and H1 is the first principal plane and Q and H2 are the second principal plane. So these all are about the written here. Here I will explain. Two conjugate point characterized by the unit positive transverse magnification or principal planes or unit planes, and intersection of these points on the principal axis Q1 to 2 points has the principal points. So here 2 principal points H1 and H2. So if you extended AB, look at AB forward direction, and the CF2 is the backward in the backward direction. They are intersect at M2. When the C2 F2 are refracted and meet here, when you take the backward, they are meet at M2. On drawing the perpendicular M2, so draw the perpendicular M2 axis, we get the intersection on the principal axis. The intersection point H2 is the second principal point. So same here also are written here. Similarly, H1 is the principal point, M1 and H1 the first principal plane, and M2 H2 is the second principal plane. Next, we will learn about these things. The distance of the first focal point is measured from the first principal point, and the distance of second focal point is measured from the second principal point. So first principal point and second principal point, how to see the diagram. If there is a same medium on either side of the system, then the both of the focal length will be equal. So when the both system are should be same on either side, object system and image system, that should be H1 F1 is equal to H2 F2. Look at here, H1 F1 is equal to H2 F2. Both should be same. So then the image of M1 will be M2, that is M1 H1 is equal to M2 H2. That is M1 H1 is equal to M2, and the object and image should be equal. So the lateral magnification of the plane will be unitary and positive. Lateral magnification already I should be discussed, that is image height is equal to the object height, or image distance to object distance. I already discussed about in previous class. Now we will last one is nodal points and nodal planes. Here first you draw the principal axis, that is x and x dash, and draw the plane. M1 and H2 is the principal plane, and also you take the principal point, draw the perpendicular line or parallel to this M1 and H2, that is take the point is F1, and draw there is another line, that is N1. When the rays start from or incident and meet at a principal point, where this point is meet, that is a nodal point, that is N1, and that making the angle is θ1. See here also second principal point or principal plane, that is S2 M2, this is the principal point, and there is another focal point, that is F2, and draw the perpendicular line, that is second principal focal plane. And when the light rays incident here, and where that point is incident, that is nodal point N2, that making the angle θ2. So here let us know about two conjugate points on the principal axis. For example, N1 and N2 are the two conjugate points on the principal axis of the optical system, characterized by the unit angular magnification are nodal points. So unit magnification, that is angle, it is image angle equal to or ratio of image angle to the object angle, that is θ1 and θ2, that should be value should be 1 or unity. So plane perpendicular to the principal axis and passing through the nodal points are known as nodal planes. For example, it is a point, we draw the perpendicular line to the first nodal point, that is a first nodal plane, and if you draw the perpendicular line on the principal axis, and that should be meet on the second nodal point, that is a second nodal plane. So these both nodal planes. The distance of the nodal points are measured from the focal point. These nodal points distance are measured from the focal point, that is F1 and F2. So these all are about the cardinal points. So totally 3 pairs, and one is the pair of focal point and principal point, pair of principal point, pair of nodal point, or we can take it as a two focal point to principal point to nodal point. These 6 nodal points we can call it as a cardinal points. Next I will going to explaining about the Newton formula and our image formation. So look at here, this is a diagram. This is a diagram, this is a principal axis, and for example I will written here a ray parallel to the principal axis. A ray is parallel to the principal axis. After refraction from the lens system passes through the focus point f2. So this is a ray passing through the optical. This is a optical system. For example, it is a lens, thick lens or thin. There is a optical system. Number of lenses is called optical system. When the ray is incident and takes the path and it is refracted and meet at the f2 point. So the ray passing through f1. So there is another ray. They are passing to f1, and become parallel to the principal axis after the emerging from the optical system. This ray is passing and meet and passing from this optical system and emerges. It is a parallel, but here is converges. When the parallel ray is incident and it should be converges. When the ray is passing f1 and meets, this ray is makes to emerges out from the parallel to the principal axis. So ray of emitting first principal plane at a height of emerges through the second principal plane from the same height and on the same side of the optical system. So this, what are the height when it is incident, and same here, and look at here, after the emerging the same height will be there. Incident, what are the height is there, the ray, same after emerging out the height of the ray is also be same, there is no change. A direct towards the at a nodal points n1 emerging through the another nodal points n2 parallel to the previous ray. For example, the rays, next slide we can see here. So when the ray is passing and incident here and it draw the extended part, we get the nodal point n1. After when it is incidenting and you draw like that and it is refracted and after the refraction, this is the image point, it is the object point. When it is refracted, that is n2. So we extend this point, we get here. When you are extending after refraction, it will meet at a1 line. So after it is refraction f2 and passing here, and b1 and e2 is the image, height of the image y2. It is a object, it is a object, it is a object, it is a image. Object image is we will get here. So it is the x2 is the distance of the image from focal point f2 to image point b1, and f2 for second focal length, that is f2, and this is the distance. We see here f1 is the first focal length and x1 is the object for object distance, that is object to first focal point, that is the x1. So look at from triangle AB f1. So triangle AB f1, it is an, and another triangle, that is triangle A f1 k1 h1, f1 k1 and h1, they are similar triangle. So automatically we all are know about the trigonometry, similar triangles. For example, k1 h1, k1 and h1, this side and this side, the similar triangle, this side and this side also be same. For example, k1 h1 divided by AB is equal to the side h1 f1, h1 f1, this side, and also similar triangle, automatically another side B f1 should be same. Automatically k1 h1 we can also take it as a AB, or h1 k1 we can take it as this height and this height should be same, because already we studied in before slide, this height and this should be same. That's why instead of h1 k1 we can use the b1 or a1 b1. So see here is equal to same h1 f1 divided by b f1, same it is ab. Now we can cross multiply, or we can take it as the a1 b1. Here a1 b1 in a negative, in below side you always height, when the height is in principal above, in sign by sign convention you take it as a positive. In principal axis below, what are the distance, you have to take it as a negative. That's why a1 b1 is equal to minus y2. We look at here, and ab, that is a object distance or object height, that always above the principal axis, that should be taken as a positive. That's why y1. So put this value in above equation, that is h1 f1 is equal to, so before that h1 f1, look at here h1 f1, it is take it as a f1, but is distance is object distance always negative, and image distance you will take it as a positive. That's why here minus f1. And also bf1, look at here bf1, it is also object distance, that's why it is negative. In optical center, from the negative side always take it as a positive, in right side, in the image side you take it as a positive. You already know about very well in by sign convention. That's why minus x1 from this diagram. Next you put these all values in this equation, you will get like that. Next from triangle, similar, I had taken before slide, this triangle and this triangle are similar. Now I had taken this triangle, from triangle a b1 f2, a b1 f2, this is one triangle. Another triangle is triangle f2 h2 and n2, f2 m2 h2 and f2, this triangle and this triangle, they are both are similar. Automatically you take it as a first sides, that is a1 b1 divided by m2 h2, and is equal to side, that is b1 f2 divided by h2 n2 or f2 h2 f2. Now we can take it as a a1 b1 has this, but m2 h2, it is same or similar height to this AB. That's why instead of m2 h2 we can take it as a AB. Look at here, so AB. Next as it is b1 f2 divided by h2 and f2 as it is. Now you change the sign convention, that is a1 b1 is negative y2 and AB is positive, that is object distance, distance measured from optical center to object distance, that is always positive, that is y1. As it is f2 h2 f2, look at here f2 and h2 distance always you know f2. That's why x2 value, that is x2 value b1 f2, that is x2. Put these all value in this equation, we will get in below. Next when you are simplifying or comparing the equation, finally we get x2 divided by f2 is equal to f1 divided by x1, and cross multiplication x1 x2 is equal to f1 f2. It is a Newton formula. So if the medium is available on either side of the system, if same medium is available on either side of the system, so automatically f1 is equal to minus f2 is equal to, commonly we can take an as a f, when put this value here f1 f2, that should be f into f, that is f square, x1 x2 is equal to f square. This is the final expression for this video. So this formula is known as a Newton formula, and also we studied about the image formation. So these all are about the cardinal points and Newton formula and image formation. So hope you understand. So if you know, I will send the PDF file in the group. So please refer carefully. If you don't understand anything when your class started, I will explain once again, or I am going to revise the topic. Please concentrate and give the interest on the topic. Thank you so much.